Alright, today's lesson is on probability with dependent events. And so by the end of the lesson, we're going to go ahead and be able to solve and determine the probability of two or more events occurring together. What are dependent events? The probability of one event occurring affects the probability of another event occurring. The second event depends on what happens on the first event is the best way to describe it. Okay. So how does a gumball machine help explain dependent events? So if we have this gumball machine right here, and we have a total number of colors in there, after the first gumball's picked, there is one less gumball in there that you can possibly pick. So your total number of gumballs are going to go ahead and go down by one. Also, whatever color got picked is going to go down by one also. So you're going to have less of a chance to pick that color. Okay. So let's go ahead and think about our first problem here. And again, this is without replacement. Usually your dependent events are without any replacing. You don't get a gumball out and then put the gumball back in. You actually would keep it, and then your chances of getting a different color change. So what is the probability that you can get two red gumballs from the machine? Alright, so that's our question there. So before we can go ahead and find out the probability, we have to find the total number of gumballs in there. So you need to go ahead and add these up. If I go ahead and get my calculator here, add them up in my head, and say 45 by 25 plus 25 is 70, 85, 115, 135, and I have 150 total gumballs in there. Okay? So the probability of my first event, my first gumball, out of 150 gumballs, there is 30 red. Okay? So after that first gumball is picked now, though, I have one less total gumball in there. So the probability of my second event is going to be out of 149. Not only do I have one less gumball in there, I have one less red gumball because I actually picked the first one. So I'm not going to have 30 red gumballs to choose from. I'm now only going to have 29. And if I go ahead and solve these or simplify them, I actually get a 1 over 5, or it is a 20% chance, 0.2. And my other one, I'm going to go ahead and plug into my calculator. 29 divided by 149 is going to equal a probability of 0.195 rounded to it, which is equals 19.5%. So you can see that my probabilities of picking a red gumball and a red gumball are different. Okay, I have a less of a chance of picking the second one because there is one less to pick from. Alright, so how do we determine the probability of the first event? We could say red gumballs divided by or over, let's say total gumballs. And then how did you determine the probability of the second event? We would go ahead and say, again, it is the red gumballs. Okay, we're going to do -1 though, because we took away 1. And then we had our total gumballs, also -1, because we took away from it. And so I asked my question of what is the probability these events occur together? Now here's where it changes a little bit. In order for these to occur together, the first one has to occur, which is we'll use the 1/5 simplified fraction. Okay? That's the probability of the first event occurring. If I want my second event to occur as well, it is going to be an AND. My first event occurs and my second event occurs. Whenever I have that AND word in there, I have to go ahead and multiply these two. Alright? Because I'm saying this will happen and this will happen. I can't do a red and then a different color. I can't do not a red and then a red. It has to both occur. So that's why I'm going ahead and multiplying. So if I do 1/5 times 29 over 149, I end up getting 29 over, let's multiply 5 times 149, 745. And 29 is a prime number, so I know nothing's going to go into there, so this is the simplified fraction that I'm going to go ahead and get. So my fraction is 29 over 745. I can go ahead and divide those to get my decimal, and I get an answer of 0.03, and it goes 89, but I'm just going to go ahead and simplify or round it to a 9. Okay, So 0.039 multiplied by 100 to go ahead to a percent, and I get 3.9%. So it's not likely this is going to happen. I'm going to get 2 red, but it is possible for it to happen. Okay. All right, number 2. I have, what is the probability that you will get the red gumball and then a blue gumball? So I'm going to go ahead and be using my same totals from up top here. Okay. So first question is how do you determine the probability of the first event? The first event is a red gumball. And we actually already did that. That is our 30 out of 150. Okay, that's our 1/5 or 20%. All right. My second event now is not pulling a second red gumball, but it is pulling a blue gumball. Okay. So if I look at my totals up here, I actually have 45 blue gumballs. So it is going to be 45, and it's not going to be out of 150 total because one of the red ones is already pulled. So now it's going to be out of 149. Okay. So if I do 45 divided by 149, I get an answer of 0.302, which is equal to my 30.2%. Okay. And then what is the probability for these events to occur together? In order for them to occur together, I have to do my first one, which is my red, and my second one, which is my blue. And I'm going to multiply those together. So when I multiply them together, I get 45 over 745, 5 times 149. Okay, these definitely can be simplified if I wanted to. I know 5 goes into both of them. And so we can do a 9 over 149. Okay. So my fraction is 9 over 149. And if I turn this into a decimal by dividing them, I get an answer of 0.06, and it goes 0.4, so we're just going to do 0.06, which turns into a 6% chance. Definitely more of a possibility to get a red and a blue than it is to get 2 reds in a row. All right, let's go on to our next one. We have 4 homework assignments to complete in each of our core classes. What is the probability you would choose to complete your math homework first and your science homework second? Okay, so if we think about our problem here, we have 4 different options here. All right, we have our math, world history would be our social studies, or science would be science, and then we have our language arts we can go ahead and do. But it's asking me what if I did my math homework first and then my science homework. So the probability of my first event is going to be I want to complete my math homework. There's only one way to do my math homework. Okay? So the probability is going to be 1 out of 4. Okay? And then my probability of completing my second one, now that I've already done my math, that option is no longer there. Which means now I'm down to my social studies, science, and my language arts, which means I have 3 options. And my science is one of them, so it is a 1/3. Okay? So now I have a 1/4 and 1/3, and so in order for these events to occur together, I have to do both. So 1/4, which is my math, and, which means I'm going to multiply my science, it's going to be 1/3. So I have a fraction of 1/12. If I turn this into a decimal, I get an answer of 0.083 with my 3 repeating. And then if I turn it into a percent, I get 8.3%. Alright, number 4. We have 2 girls and a boy are taking a test. What is the probability that they will finish in the order girl, boy, girl? Okay. So if I think about my total number of students here, I have 3 total students. Okay, 2 girls and a boy. So my first probability is going to be out of 3 with 3 total students. girl has to be first. One of the girls. I'm actually going to write girl, boy, girl over here. There's two girls and a boy. So there is actually two chances that a girl could occur because there's two of them. If that were to occur now, though, one of my girls is gone. Okay. So my second event to occur, they now want a boy to occur. They want him to finish. There is one boy out of two possible. So the probability of that is 1/2. Now that the boy is gone, the probability of my third event to occur, which is a girl being there, there's only one option. 1 out of 1. Okay? And if I think about how it is for all of these events to occur together, which is what my question is asking me again, it has to be first event 2/3, which is my girl, and the second event has to occur, which is my boy, which is 1/2, and my third event, which is in the last girl. There's only one girl left out of one student, so 1 out of 1. I'm going to go ahead and multiply those all together, and I get an answer of 2 out of 6, which simplifies to 1/3. So my fraction would be 1/3. Turn that into a decimal, and I get 0.3 repeating. Multiply by 100 to get to my percent, and I will get an answer of 33.3%. And 3 is repeating. What I'd like to go ahead and do right now is pause your video. Go ahead and answer the following 4 problems. Once you've actually tried those problems, let me go ahead and restart your video, and we'll talk about your answers. So again, you need to write your answers in a fraction, decimal, and percent form and round to the nearest thousand. The first question is probability of choosing 2 vowels without replacement from the word probability. I went ahead and underlined here. You found that there are 4 vowels in the word probability. So it's going to be, there's 4 possible chances there. But it is without replacement. So the first value you should have done 4 out of 11 because there's 11 total letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 4 out of 11. And the second vowel will be 3 out of 10 because you've taken one of the vowels away, which means there's 1 less. And you've taken one of the letters away, which means there's 1 less. So that's where we get our 4 11ths and our 3 10ths. Multiply them together because we need both to happen. And we get an answer of 6/55, 0.109 with the 0.9 repeating, and we get a 10.9%, and we just rounded it. Number 2, picking of an odd number, not putting it back, and then picking a multiple of 10 from the numbers 1 through 30. So the first one is picking an odd number. I went ahead and listed all my odd numbers out, and you should have gotten 15 of them. There is a half of the chance to do it, a 50% chance. And then I went ahead and found the multiples of 10 probability. So notice none of them are odd, so none of those could actually be possibly chosen. Okay? And so when I solve those, I get there's 3 of them, and instead of having 30 choices, there's only 29 because one of them was pulled for the odd. And so I do half times 3/29, getting me 3/58, giving me a decimal of 0.052, which is equal to 5.2%. Number 3, we have picking 2 red gumballs without replacement from 5 red and 5 blue. So I have a 10 total gumballs, and then 5 of them are red, so my first chance would be 5 out of 10. After that first red is picked, now there's only 9 left, 4 of them being red, so the second chance is 4 out of 9. 1/2 times 4 out of 9 is 4/18, which is equal to a decimal of 0.2 repeating and 22.2%. And then I get to my last one. 2 boys and 2 girls are running in a race. What is the probability that the order of finishers will be in order of girl, boy, girl, boy? I said to get a girl, it's 2 out of 4. Now there's 1 less student. So now it's to get a boy, there's 2 out of the 3 of them are boys. Now there's 1 less student for the third place person. There's only 2 left. 1 out of the 2 is a girl. And then finally the boy is 1 out of 1. Multiply it across and we get 2/12 equal to 1/6, or 16.6% repeating.